Welcome back everyone. This next lecture is another DC series resistive circuit, but this time we have 3 resistors, which is 1 extra compared to 2, believe it or not. So for this particular one, I've pre-drawn some circuits for us, just to so you don't have to keep watching me do up all these circuits. Let's have a look at this first one. We've got 6 volts applied voltage, and then 3 resistors, R1, R2, R3. Now, we've got R1 at 1K, R2 at 2K, and R3 at 3K. So something that I want you to start to think about a little bit more is that the bigger the resistor is, the more voltage it will get. So we've got 6 volts here. That will get some of that 6, that will get some, and that will get some. The 3K, being the biggest resistor, will get most of that 6. The 2K will get the second most amount, and then the 1K getting the least. So let's do some calculations and see if that holds true. So RT is 1K plus 2K plus 3K. So 1K plus 2K plus 3K. Oop, writing kilohertz there, not kilo ohms. Equals 6K. Total current, so that's this current flowing through the circuit like this. In fact, just before we calculate that, if we were to replace all 3 of those resistors with one single resistor that was 6K, that would give us exactly the same amount of current as those 3 resistors who add up to 6K. So again, we can always bring back our resistive circuit to something that looks just like that. However, we do have 3 resistors, so let's keep going with this particular one. Total current is going to be your applied voltage, 6 volts, divided by the total resistance, 6K. Bring up our calculator. 6 volts divided by 6 exponential 3 to get 6K, and it's 1, and it's negative 3, so it's 1 milliamp. Alright, voltage across resistor 1, we have 1 milliamp going through resistor 1, because it's a series circuit. The current through every single component is all exactly the same, 1 milliamp. So voltage of resistor 1, that is going to be 1 milliamp, the current going through resistor 1 multiplied by resistor 1, 1K ohm. So there's our 1 milliamp already in the calculator. Multiply that by 1K, gives us 1 volt. Hopefully you can guess what VR2 is going to be, since it's twice as big as the resistance of R1. So there's 1 milliamp of current flow through R2, multiply that by 2K, and if you like, here's the calculator. 1 milliamp times 2K is 2 volts. Now, 2 ways that we could get VR3. We could do 6 volts, which is total, take away 1 volt, take away 2 volts, that would leave us with 3. Or we could do it as we've been doing it here. There's 1 milliamp flowing through R3. The resistance of R3 is 3K ohms. And I probably don't need to do this on the calculator, but let's keep doing it. 1 exponential negative 3 for 1 milliamp times 3 exponential 3 for 3K, and we get 3 volts. 1 volt plus 2 volts plus 3 volts is 6 volts. Alright, very good. Let's do this next circuit. So quite a few different resistor values here. 15 volt power supply this time. R3 is quite a bit bigger than the other ones in that it's 4.2K. The next biggest is 700 ohms, and the third is 150 ohms. First of all, what is RT? Well, RT is going to be, actually I'll write it up here first, 150 ohms plus 700 ohms plus, what do we got here, 4.2K equals, so let's write this in, 150 ohms plus 700 ohms plus 4.2K, and we're getting 50-50, or 5.05K if you like, both the same thing. Total current, well, we need the voltage, 15 volts, divided by the total resistance, which is 50 ohms. 15 volts divided by 5,050 ohms, and let's get engineering notation up here, display engineering, 2.97 to the negative 3, which means 2.97 milliamps. So the amount of current in this circuit is just less than 3 milliamps. And again, that current is the same through R3 as it is through R2 as it is through R1. So therefore, let's figure out these voltages. Voltage of resistor 1, we need that amount of current, 2.97 milliamps times 150 ohms. 2.97 milli, so exponential negative 3 for milli, multiplied by 150, and it's not even a volt. In fact, it's not even half a volt. It's 445.5 millivolts, because we're looking for voltage here. 445.5 to the negative 3, so it's millivolts. VR2, so R2 is, well, it's nearly, what, 5 times as big as R1, so it should have nearly 5 times as much voltage as R1. So let's check that out. We've got the same amount of current, 2.97 milliamps, 700 ohms this time. 2.97 exponential negative 3 multiplied by 700 ohms. 2.08 we would round that to. 2.08 volts. And finally VR3, the biggest one at all, at 4,200 ohms or 4.2K. It's got the same amount of current, 2.97 milliamps, multiplied by 4.2K. 2.97 milli multiplied by 4.2K. 12.47 volts. 12.47 volts. So you can see that one is getting the vast majority of that 15 just because this one is so much bigger than any other resistor. So let's see how this checks out. 12.47 volts plus the 2.08. Oops. 2.08 plus, what was the last one? 445.5, and that's milli. So we need to do exponential negative 3. And you can see we're getting, I mean, you'd round that to 15. So we've been rounding to 2 decimal places, and so when we add them up again, we'll find that our rounding's going to be ever so slightly off, but you can see it's very close. So 2 decimal places is quite good accuracy. So that is an example of that's 2 examples, I should say, of using 3 resistors in a circuit. So stay tuned for the very next one, because after you do your quiz, we're going to look at examples of what you can do with a single resistor circuit, a resistor circuit with 2 resistors, and then with 3 resistors. Thanks for watching, guys.